afternoon. Welcome to the Royal Studio at the University of Scranton and Coffee with Conniff. I'm Brian Conniff, Dean of the College of Arts and Sciences at the University of Scranton. Our feature blend today from Northern Light Espresso Bar is Rally Blend. It's a mix of toasted almond, dried cherry, and milk chocolate, fairly traded and organic. My guests today are Professor Nick Truncale from our Department of Physics and Electrical Engineering, Peter Kulick, Junior Electrical Engineering major, Aubrey Savage, first-year Computer Engineering major, and Natalie Krupka, second-year Physics major. Welcome.
Good to be here.
So, Professor Truncale, just 2 weeks ago we were at TechBridge.
I recently started a company that creates STEAM education curriculum and then also packages with that curriculum our own educational technology. So if you don't know, STEAM is science, technology, engineering, art, and mathematics. So my team at Nexus Valley, we had to put together a business plan for our business, and we entered that into the TechBridge Business Plan competition. So 2 weeks ago, I believe tomorrow, we were at the awards banquet at the FM Kirby Center in Wilkes-Barre, and we ended up getting the Wild Card Award, which gives us some cash for the business, but then also a really big list of in-kind prizes to help that business go forward. So the whole genesis behind the business was we have a course here in the Physics and Electrical Engineering department called Foundations of Physics and Electrical Engineering. In that course, students learn some first-year oral communication skills and also first-year digital technology skills. But then we also integrate some STEAM skills that'll help them in their careers as engineers and physicists. And one of the main things that we do as a capstone experience in that course is they work with these robots that you see here on this table to solve a micromouse maze. And they do this as first-year students their very first semester on campus.
So we've got a direct line here from first-year physics, engineering students, right to starting a company.
Right to starting a company, right?
Because there's a couple of interesting things. I think when people think of universities and when they think of colleges of arts and sciences, they don't always think of us as places that innovate, that spin off companies and make that kind of difference in the society. So one of the interesting things about that is your company, recently winning, is a project you've done with one of our recent students, Nathan Williams.
Right, so Nathan's my business partner. He recently is graduating from the University of Scranton. He's more of the tech side of everything, and then I do more of the curriculum education side. And I might want to mention too that TechBridge, one of their goals is technology transfer from the educational community of northeastern Pennsylvania into businesses. So this fits right along with their goals, and I think the goals of specifically the College of Arts and Sciences here at Scranton, where we're trying to help the community at large. And one of the things that Nexus Valley Solutions, one of the things that we do is we're trying to get these STEAM solutions into schools so students can learn about STEAM earlier in their careers so that when they go to college, hopefully at the University of Scranton, they can choose majors that are involved with STEAM.
Great. So we also have a window into the life of our undergraduate students and the kind of education you were getting here, how it might be a little different from it would be at another university. So let me turn to our students. Could you say a little bit, how are we doing so far with our majors in physics, computer engineering, electrical engineering?
Well, physics-wise, I'm doing really well. The major itself is very challenging. A lot of the work that you do is by yourself, or you can work, for the most part, one-on-one with the teacher. I've had a lot of opportunities to work on some pretty cool projects. With Professor Truncale specifically, last year we worked on an emission and absorption spectrum analysis of rocket fuel, and I thought it was a pretty cool project as a freshman, to be able to do something pretty involved. And we're currently working on another project now, so I'm just looking forward to the projects to come.
2 years, 2 projects already.
Yeah.
Professor Truncale's class is kind of the only class I've had to deal with anything relating to engineering. The other classes that I'm in are computer science, and that's kind of just the basics right now. But Professor Truncale's class really opened my eyes to this whole aspect and made me realize that I want to stick with this engineering really early in my college career.
I'd say the same thing. I'm a junior now, so I've taken most of the engineering classes here at the university. The only class I have left is the capstone senior year. but starting from Professor Truncale's class piqued my interest right away.
We educate our students to eventually become our collaborators, our partners in our research. That's a very unusual kind of approach. I mean, I don't think anybody but the Jesuits was doing this, say, in the 16th century. But here we're really doing it. 470 some years later, we're really doing it, right? So you guys are on your way to being partners in maybe the next business we're spinning off or something like that, right?
Well, what we do and for this specific course is the winners of the course competition, they go on to actually compete at a regional electrical engineering conference. And then we ask those students to then come back the following fall and be the teaching assistants for the course and also help to improve the robots. So Natalie did that this past fall, and Aubrey doesn't know yet. I haven't asked her if she would like to do that, but she's on that list if she would like to.
Consider her, yes.
Consider her, yes? Okay, good. But so it's this continuous improvement of the course and our curriculum, but then also involving the students in that process as well, I think is super important, because then they take some ownership of the course.
So we have this little tradition in my office, right? Around late November, December or so, we walk down the hall to your area, where our first-year students are trying to get their robots to go through the maze. I don't know if it's for the first time, but some are doing better than others.
True.
Right? Some
Yes.
are banging into things. Some are going in circles when they're supposed to be going straight. As an English professor, I always enjoy seeing this. But that's what I see first, towards the end of the first semester. Then I learn, I don't know, April, May, we're winning competitions.
There's, I guess, a funny story with Natalie. Do you remember what I said the very first day of the class for Engineering 150?
What that you would teach us.
Yep.
Everything that you need to know to code a robot. And I remember sitting in this class for the first time. I mean, I had come to visit Scranton, and I specifically remember seeing these robots and the team that was moving on to SAC that year. And I was just visiting, and I loved the way that the team was working together and how they could explain everything that was happening, and it looked like a piece of cake to them. And I thought to myself in my head, I'm like, there's no way that I would ever be able to do something like this. And then I was sitting in Truncale's class, and he said, I'll teach you everything you need to know to simply code a robot. So it's actually a very simple project if you know anything about computer programming. I didn't really know anything programming-wise
So
before
when you
I
say
came.
code a robot, you mean
You are legitimately coding a robot, and I kind of had no idea what that meant. I'd never really seen code before, but he teaches you anything that you need to know, and even more.
so then we're winning things in the spring, right? And we're competing against Ohio State, Penn State.
Yeah. So
schools
the
like
region of IEEE that we compete in is Ohio, West Virginia, obviously Pennsylvania, Maryland, lower southern New Jersey, Delaware, Washington, D.C., and northern Virginia. So just think about some of the big schools in that area, and we're going up against these Penn States, these Ohio States, these Drexel universities. And our first-year students are getting first and second place in this Micromouse competition.
On the note of competition, a couple of years ago or so, we were in the Cornell Intel Cup.
Oh, yeah.
Right?
Nathan was a part of that, too.
And we're waving to Nathan
Yeah.
who's off in the shadows. He's sort of one of the mastermind behind a lot of this. But we were third in the nation.
Yeah, yep. So
I
that
mean,
project
not
was
like
cool.
third in northeastern Pennsylvania. We were third in the nation, right?
And I remember a quote, because you came to one of our department meetings, and you said, if you were third place in the NCAA basketball tournament,
Yeah.
we would have been on national news, right?
Yeah.
Yeah.
So again, not to be overly competitive here, but the schools we beat included Carnegie Mellon.
Carnegie Mellon, there was University of Pennsylvania.
Yeah, them.
There were a lot of Northeast schools. Well,
Yeah.
Cornell sponsored it, so I think just because of their
Yeah,
general
right.
relationship in that region. But there was, West Coast schools as well.
Talk to me about this a little bit. So I asked Professor Truncale this. I asked many people this. Like, when these things happen, all right, we win this competition, we win another competition. I'm not an engineer, but I don't believe for a minute that happens by accident, right? There's got to be certain things we do very intentionally that make that happen, right? So that's one question, I guess, coming. The other thing is, to me, that must have something to do with studying engineering as part of a liberal arts college.
Well, the big thing about the code is you get to start from scratch. So everyone's code looks different. Like, nobody's looks the same. So that right there is kind of like your own artwork, I guess. Like when I was looking at mine, like it's like your little baby. But then if I ask Peter, oh Peter, like, you know, something's not working right, and like he looks at my code and he's like, oh yeah, I didn't do the same thing as you. You did it a different way, but I could see where you're coming from. It's like everyone can work together, and I can explain it to him even though he's older than me, and he can help me figure out my problem, and it all works out.
Earlier today, I got my pre-publication copy, which sounds kind of cool, of a new report from the National Academies of Sciences, Engineering, and Medicine. All right? It's called The Integration of the Humanities and Arts with Sciences, Engineering, and Medicine, Branches from the Same Tree, which is a quote from Albert Einstein. What they recommend in the end, after 280 pages of studies of various kinds, is supporting courses and programs, now listen to this, that integrate the arts and humanities with the natural sciences, social sciences, technology, engineering, mathematics. That's what that is, right?
Pretty much. It's exactly why I think this course is popular within the department, because you're integrating all these different disciplines and, I guess, skill sets into one place, so that you could leave this course and get an internship, only because I'm looking at Peter, because he got an internship and he programmed in that Python programming language.
I did program in Python.
And, you know, this is where he first learned how to do that. So it just opens doors, I think, for the students as well, for sure.
And that note of opening doors, where's your internship?
Well, last year I interned at Crestron Electronics over summer.
So you know the little panels on the walls to set the projectors on?
Yeah.
That's Crestron.
Oh,
Yeah.
great, great.
And then you got an REU this summer.
Yes.
One of the things that a lot of people don't understand, you know, like I'll tell them that I'm from the University of Scranton, and they'll ask me, you know, like, what are you studying? Like nursing, you know, like one of those types of majors. And I say, no, physics. And they're like, oh, you know, like, how is that? Like, I don't know Scranton for their physics and engineering department. And one of the things about it is that is something that I love. It's the fact that we're a small department, which creates a lot of relationships. So you're able to have a lot of one-on-ones with your teachers, and you're able to do a lot of projects that I feel like you wouldn't be able to do if you were at a larger school, or a school where engineering and physics is like the main thing, you know. And it just opens a lot of doors. You get to meet a lot of amazing people, and you get a lot of opportunities that you wouldn't have anywhere else, I would say. So I think that that is kind of something that's really special about our department.
When our majors get jobs, the feedback we get from those employers are that our majors can go into a room and give a brief about some project that they're working on at that company.
Right.
And they could do that like second nature, because they do a lot of presentations here and all those soft skills. They learn a lot of soft skills here in the liberal arts community. So I think that's one thing that sets University of Scranton apart from others, and I'm sure you've heard that from other people before.
Well, and to say nothing of, according to the National Academies of Sciences, Engineering, and Medicine,
I didn't even know I was teeing
we're
them up.
about 475 years ahead of the time.
Oh, good.
So, you know, we're right on
Perfect.
course with that. Well, thank you to our guests, Professor
Sure. Thanks for
Truncale,
having us.
Natalie, Aubrey, Peter. Thank you to Northern Lights for the Rally Blend, very, very fine cup of coffee. And thank you to our production staff here at Royal Studios Department of Communication.